All right, so welcome to the Cairo session for today. Even though it's going to be mostly live coding, we're going to have a few slides just to put people in context before we jump into Starlings. We're going to talk a bit about Cairo and the meaning of the word, a little bit of its history of its development. We're going to talk about field elements, which are going to be a crucial data type in Cairo and the whole of a Starknet in the Cairo VM. Then a little intro to Starlings. We talk about homework, and we go straight to the live coding. We're not gonna have any quiz or tests for this session like we did for session 1 and 2, because it's gonna be live coding, and the homework will be the replacement of your checking your understanding. So let's start with Cairo. So Cairo is a confusing name because it's used to describe multiple things that, even though they are related, they're not exactly the same thing. So Cairo originally actually referred to a type of computer architecture created by Starkware to allow for the creation of the validity proof out of the execution. And the meaning of the Cairo is because it was like I don't know, what's like an abbreviation or transliteration of the word CPU air. So if you take like the C, the A, I, R, you get the Cairo, and then you get the O, that's why Cairo. And air means algebraic intermediate representation, right? Which is like the first step of creating a validity proof with CK Starks is called the arithmetization. So when you think about the CPU architecture that Cairo uses and Starknet uses, it's actually called the CPU air, and that gave the name Cairo. Now, the low-level bytecode that is executed in this type of CPU created by Starkware is known as the Cairo assembly, or we sometimes just refer just as CASM as an abbreviation. Yeah, so people thought that Cairo came because of the Egyptian city. I mean, it's a play on the word, but the real reason it's called Cairo is because CPU air. So, okay, so I mentioned there's also the low-level language, the Cairo assembly, right? That also uses the word Cairo. And then we have the high-level language that compiles to Sierra and then compiles to the Cairo assembly that we also know as Cairo, right? So far we have three meanings for the CPU architecture, the low-level language, and the high-level language. Just one is CPU air, one is Cairo assembly, and one is just Cairo. So the old implementation of the high-level language is known as Cairo 0, that is now deprecated. So Cairo has been around for, I think, since 2021, I think, or 2020. I think we have a timeline there. So the first version of Cairo was a very low-level language that looked a lot like Cairo, like assembly language. If you ever dealt with one of those, usually like studying computer science, it was very difficult to use, but it gave you glimpses of the power of this technology, right? That you can prove the execution, but it was not developer friendly. That language of that version evolved maybe a year and a half ago into what today we know as Cairo, that resembled more like the syntax of Rust. So that is what we call Cairo today, the modern syntax. The Cairo 0, that has been deprecated, so we don't have to care that much. But you're still going to find here and there some smart contracts between Cairo 0 just because of legacy reasons. One of those is the Starknet OS. It's like a public good also in the Starknet ecosystem that is in charge of basically interfacing the sequencer with Sharp to create the proofs. That's one of the few things that is still written in Cairo 0, and also the universal deployer as well is written in Cairo 0. But you as a developer, you will never have to write in that language anymore, just high level. And of course, as you mentioned, Cairo is the capital of Egypt, which makes the work trying to search for Cairo and trying to get us a match, something related to Starknet, is very difficult. So it's terrible for search engine optimization, something that we learned just after we named everything. So a little bit of the history of Cairo, the language in this case. So in 2018, Starkware published the Stark white paper, just defining CK proofs work. Then in 2019, Starkware creates the first, let's say, like a software as a service using this technology called the StarkX. And the StarkX was like it was more like a hard-coded capabilities that, allow for trading some tokens and things like that, basics that in a way that can be verified and settled on Ethereum. But there was no programming language. Every single circuit required to do these operations were written by hand, basically. In 2020, say, okay, how can we actually stop writing polynomials and circuits by hand, and we actually have some kind of language that writes that for us? Or at least that we can just focus on writing the logic and not care too much about the math behind it. That was the motivation to write the first version of Cairo, what we now call Cairo 0. And Starkware took this Cairo and they said, okay, let's rewrite how StarkX work using Cairo, Cairo 0 in that case. So in 2021, Starkware published the Cairo white paper. I encourage you to read this white paper, especially the Cairo one. I think it's very interesting. You get to learn a lot about the computer architecture behind it. And in 2021 also, that's when Starknet was created finally. And it is the first time that Cairo was used to create smart contracts. Up until this point, it is still using Cairo 0, the old language, but it was possible to write smart contracts even back then. Finally, in 2023, that's when the new version of the Cairo programming language, that back then we call it Cairo 1, now we just call it Cairo, but that is the language that we're going to learn today. That was when it was released. So since then, we've just been improving and adding capabilities to the language, making it more easier to use, ergonomic for developers, and more user-friendly. So I like to compare like the how to use Cairo as its own language on smart contracts. Like Cairo is for a Starknet what Python is for Django. If you ever use Python or Django, you'll know Django to create a website. It's really just Python with a few extra things that you can use for a specific purpose. The same goes with a Starknet smart contract. It's just Cairo with a few new attributes and macros that you have available just for a smart contract, but it's the same language under the hood. But you can use Cairo just on its own, the same way that you can use Python just on its own to write, maybe not smart contracts or maybe not websites, like in the case of Python, but general purpose programming language, use Cairo. I like to call that Cairo Vanilla Cairo to compare it to, or to contrast that to Cairo for Starknet, but you can also call it whatever you want. So that the focus of today is going to be Cairo on itself, not for a smart contract. That's going to be section 4. One feature of Cairo, and to me, the only place where something about the architecture of how the CPU works leaks into the language, is the field elements. The field elements is usually not just as felts, and is the default data type in Cairo, right? So the default data type in Cairo is felt 252. It means it's a field element of 252 bits, which is different from the default field type on Ethereum or in Solidity, which is the unsigned integer of 256 bits, right? So it's a little smaller, less bits, but also has other properties. So a felt can represent a value between 0 and p being a large prime number. And this is a feature of how this technology of zk-Stark work. You have to choose a large prime number to define the upper bound of all the operations that you do. And then all the operations are actually apply modulus p, so that they can wrap around. And that's a requirement for creating validity proofs. In the case of Starknet today, that prime number is very large. So the exact number you see it here in the screen is 2 to the power 251 plus 17. It's a big number. It's a big prime number that can be stored in 252 bits, right? So it's not exactly 2 to the power to 252, which you would normally assume in computer science. It's actually just a prime number that is so big that you will need that many number of bits to store it. By the way, this is for now, just as thinking about the future. Starkware is building a new generation of the zk-Stark validity proof and sharp that is using a field that is much smaller. It's called the Mersenne field. It is only 31 bits, which is going to greatly improve the performance of the whole system. But for now, we are stuck with this large prime number. But just keep that in mind. If you ever hear about this 2 prover, that is what really is behind it. How can we use a much smaller field element, or a much smaller field with a smaller prime number in order to have more performance computations? Now, as I mentioned, because the field is bound on the upper side with this prime number, every operation is applied mod p. So if you do, I don't know, 2 plus 5, you really are doing just 2 plus 5 mod p, and p being this large number. So as a corollary, a felt can overflow and can underflow because of this modulus p, which means that if you define the division 1/2, it's not really 0.5. what is actually happening under the hood is p plus 1 divided by 2. So it will give you a very large number that the computer can interpret what's happening there. But when you read the numbers that if you try to print it, you will say, wait, this is what is this large number coming from? It's just the way that field elements work, right? The basic thing for ZK proofs. Luckily, we have signed and unsigned integers to solve this issue, right? So when you define a value or a variable to be an unsigned integer of 8 bits, 16, 32, 64, 128, 256, or usize, which is let's say a shortcut for U32, you don't have any of those issues anymore, right? No more underflow, no more overflow. If that ever happens, you're gonna get a failure. The compiler is gonna fail. It's gonna tell you, hey, you're overflowing. You're not managing that. Because in the case of a fail, when it overflows, it doesn't tell you anything. It's a valid operation. So the important here to remember is that failed is a thing that you hardly ever use. You should always stick to unsigned integers. I don't think integers are currently supported. They're currently supported for just regular Cairo. I don't know if for smart contracts. That is a good question. We need to check because yesterday we have a big update on Starknet, and this update included parallel execution, block packing, blah, 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 so the performance improved a lot. But it also included a new version of Cairo, the language that is now supported on Starknet. So I'm curious, maybe now signed integers are also supported on Starknet. You can take a look. You can go to the Cairo package. So, GitHub, Starkware. See if I can find some of the release notes. Let's see releases. So right now, I know the one that has been deployed to Starknet is 2.7.1, at least available on mainnet. You can take a look at all the things that have been added. Okay. Yes, signed integers are now supported. I need to upload the slides. So, okay, so always use either unsigned integers or signed integers. Don't use failed unless you really know what you're doing. Some people like to use it for if you want to, extract maximum performance or storage, you use just at the bit level some operations. You can, but as a regular rule of thumb, just use signed and unsigned integer. All right. So that's pretty much all for the slides for today. Just put your people in context. The real goal of today is to solve Starklings. And Starlings is an interactive tutorial for you to learn Cairo. It was created by Shrami, you see here with the big glasses. And the original version was meant to be like a Rust program that you run in your... But then Damien took this idea one step further and actually created a whole web application where you can run Starlings directly on your browser without having to install anything, which is way more convenient. And that's what we're going to use today, the Starlings app. And it's maintained by the community through Only Dust. So if you've never seen Only Dust, it's basically a platform where developers get rewarded for contributing to open source projects, in this case for Starknet, but I think it also supports like Solidity, if I'm not mistaken. Okay, so for the live coding, we're gonna go to the Starlings app. You're gonna have to connect your GitHub account to Starlings, and then we're gonna solve all the exercises one by one. I'm gonna solve maybe the first 2 or 3 myself, so you have an idea how it works. Then I'm gonna actually give you time. So for each exercise, I just discuss the requirements. I give you a minute or 2 to solve it yourself, and then I solve it myself live and do it together. Scandish is asking, does Starlings ship a Cairo compiler to client or processing happens somewhere else? Yes, I think it actually runs the Cairo VM in Wasm in the browser directly. Yeah, it doesn't prove anything, right? We are not here to prove, let's say, the client side proving is very expensive to do computationally. So here's just executing the code and just making sure that you complete some unit test that is actually good, but it's all running in your browser, I think. In your browser? It's a good question. I don't know. Maybe I don't know if the unit test verifying that you completed the test is being run on a backend. That will be a question for Damien. But you don't have to install anything. That's the point. All right, let's see if you have any question. I know Carlos is answering one. I'm going to see the other one. Mohammed is asking, can you explain quickly or maybe provide a resource to see how Cairo generates circuits for loops with unknown sizes at compile time? It's very tricky to implement. I know some ZK languages like Noir do not support such a thing. Yes, that was a big issue for a long time, how to support loops. That's actually quite difficult to do with ZK circuits. I don't know exactly. The best bet is you take a look at the Cairo white paper because I know the language at least the Cairo 0, it had not loops, but like a go-to instructions, and at the end a loop is based on that. But yeah, the question is, what happens with the loop? You don't know when it's gonna stop. I don't have an answer, but maybe reading the Cairo white paper might help you out. That's a very deeper question. You can also go to the core stars in Telegram. There's a channel where all the Starkware employees hang out. So that's the place where you can ask those questions. Yeah. All right. Let's go then to Starlings. So I'm gonna go back to starklings.app, and here we are. Right? I'm gonna click on start coding. First of all, you have to connect your GitHub account so it tracks your progress. Question from Constantine: should I complete first exercise today with you to get my 20 points, or so can do it later? You can do it later. That's fine. It's just before the whole Basecamp ends, you should have completed Starlings at some point today, tomorrow, in a week. That's fine. So first of all, you connect your GitHub account so you can be so it knows who completes. So I know also who to award the points. And the best companion for Starlings is going to be the Cairo book. So I'm going to have it here next to me. Cairo book, I'm going to put it in the chat, Cairo book. So I'm going to refer very frequently to that one so you will know how to use it. So, okay, so on Starlings, you have multiple exercises. You see in the left panel, we're going to be in intro 1 right now. And it's actually more of those load exercises. It's pretty complete, right? And as I mentioned, there are some exercises that are specific to Starknet, which you will know how to solve in session 4 when we talk about Starknet. Each exercise is going to have some kind of description or a hint, and then there's a button to compile to see if you completed the step. Herman is asking, I was solving Starling, but locally with the Rust CLI. The exercises in the web app are the same. Can I just copy and paste my current solution? Oh, that's a good point. So you were using the original Starling that was a Rust program. I think it's the same questions. I'm pretty sure they are. So probably you can copy paste and just continue there. Okay. All right. So in this says intro 1, welcome to Starlings Cairo V1. This exercises doesn't do anything yet, but it still compiles. Cairo file getting run. Needs to have a main. So this file is valid Cairo file. All right, so this says this function doesn't really do anything, just to get used to how Starling works. Are you gonna click compile? And it says, great, the submitted code compiles perfectly. Click next whenever you're ready to proceed. So the first exercise is really not an exercise, just to get ready. But the point is that any Cairo program, you need to have an entry function called main, and it has to be called main. It cannot be called anything else. And from main, you can develop more functions, add more code, but there's always has to be the main function. This is for Vanilla Cairo. When we go to Starknet smart contracts, it's work a little bit different, but for general purpose, always have a main. Just asking, how do we know that we are above the graduate criteria for the previous sessions? That's a question that I answered before. Personally, I don't have a way to give you up-to-date information about the points. The best I can do is that when we finish session 5, send me a DM if you want to have an idea the points you have collected. This is one of the areas I want to improve Basecamp. How to make that information public so you always know where you stand and how many more points you need to collect. But as a way to be on the safe side, just go to Node Guardians and solve some additional quests, Cairo quests. They're fun to do, and they will give you 10 points each quest you complete there. But send me a DM when session 5 ends, and I'll help you out to tell you. All right, we go to the next function. Again, I'm just gonna finish 2 or 3 myself, and then I'm gonna give you time for you to complete. You can use the option to raise your hand on Zoom to let me know when you're ready. I'll solve it myself live, and we continue to the next one. But this one saying, let's do it myself. Says intro 2. This exercise won't compile. Can you make it compile? So what's wrong with here? If I try to hit compile, it should fail, right? So oops, something went wrong. All right, so how do we make it compile? So as I mentioned before, every single Cairo program needs to have an entry point called the main function, okay? So for example, a function is defined with the keyword fn. By the way, is the font size good enough? Let me know. And for example, if I call it other, let's use a different name. If I try to make it compile, it should fail. It passes. It should fail. It needs to be main. Yeah. So we go back. Fn main. Yeah, that's a reference. It should also always be named main. All right. To exercise completed. Let's go to variables 1. I'm gonna stop at some point, not yet. Let me give you a little more context. So we need to make compile this exercise. So let's try compile first to see what happens. And we have a bunch of errors. It says, for example, identifier not found. On this line, x equals 5. So we know that the issue is here somewhere, right? X equals 5. So if you don't know what's happening, you can go to the Cairo book. You say, okay, something about variables. So maybe let's say variables. You can read the whole thing, but we can see here there's a keyword called let that we can use to define variables. And that seems to be the thing missing here, right? There's no let keyword. So we can just add let. And then what we have is just a macro that will print the value in the console. So x is, and this square brackets will be replaced by the value. So if we compile, it passes. All right. We go to the next one. Let me know if you have any question. But most programming language will have something like let. If you know, JavaScript is the same. Variable tools. Let's see if there's any hints actually. So some exercises will have a hint. If you get stuck, you don't know what to do. Just click the get hint. You get some help. Or go to the Cairo book. So that here, make me compile, right? So let's see. You try again, compile. It's failing. So it says missing token terminal Q, and it's pointing to this line, let x semicolon. So what's happening here? So if you take a look at the Cairo book, if you read this section, you'll know that every time you define a variable, you have to define its value, okay? Because it needs to know what's the type of the value. So in this case, for this to work, and also you see that there's something here. You say if x is equal to 10, but we never define what the value is, so this wouldn't work anyway. And this is just a regular problem in computer and programming, not specific to Cairo. So in this case, if x is 10, it will print this on the screen. Any other value will print this. So let's have it to be 10, and we compile, and yeah, it's work, right? So we just needed to initialize the value with something. If you don't define the type of a variable, it's gonna always use a default, the failed 252 that we discussed before. That is not a good idea to use. It will work most of the time, but it can overflow. That's then probably later when we talk to primitive types, we're gonna see how to actually use unsigned integer or signed integers as a better option. So okay, so from this point on, I'm gonna give you a minute or two to complete each exercise before I solve it myself. So let's just read what the requirement is, just variable mimic compile, and we have this function. So I'm gonna give you a couple of minutes, do it yourself. Let's see what's happening. So you can see here that we define the type is explicitly defined to be failed 252. And we say, okay, here's a variable that we don't define a value. And then we're trying to print. So if I click compile, let's see what happens. Unsupported feature, yes. So as I mentioned, when you define a variable, you need to provide a value the moment you define it. So what's missing here is just give it a value. Let's give it 5, for example. And if we compile, that should work. That was all it's needed. You go to the next one. Right, so let me see what's happening here. All right, so we have a variable. We didn't define the type. So by default, it's failed 252. We define the value 3, so this should be okay. We print the value. So this should print the x is 3. And then we reassign x equals 5. And we are told that we cannot change this line. And somehow this is failing. Let's see what says the failing. I haven't solved this in a long time, so I'm actually just trying to solve it myself right now. Cannot assign to an immutable variable. All right, okay. So the issue is here, right? In Cairo, everything is immutable by default, meaning that once you define the value, you cannot just reassign another value to the variable. And this is a feature, I think Rust has the same feature. So if you want to make a variable to be mutable, you have to define that explicitly. So there is a keyword called mute for mutability, saying that now I'm allowed to modify the value stored in this variable at any time. So this should be now possible to do. See? And yes, that was the issue. And if you go to the Cairo book, they actually talk about that here somewhere. So make sure you read it. At some point, you see, they show the keyword mute. So they will give you more context about in what situations immutability is actually a good thing, what situations you will need to use mutable. So hopefully while I explain, compilation should be over. So let's take a look at what's happening here. So we have this variable number and we assign a value, but look at this value has a suffix U8. So this is one way to define what's the data type we want to use for the variable, in this case, an unsigned integer of 8 bits. The other way to define this, which I prefer, is more like doing that, U8, so you don't need the suffix. But they told us that don't change that line, so just gonna leave it this way. So now we print this value in the console. This should be fine. And then we have number equal 3. Don't rename this variable. And something fails. So let's see. If I compile, cannot assign to an immutable variable. Aha. So we have the same issue as before. By default, every variable is immutable, right? So if we want to do this reassignment, we need to make this variable mutable. So let's try again. The submitted code compiles, but you are not following the exercise rules. Oh, I cannot change this line. Sorry. All right. So how do we make? What if I reset this? Let number. Can I do something like this? Let me see the hint. In variable 5, we already learned how to make an immutable variable mutable using a special keyword. Unfortunately, this doesn't help us with much in this exercise because we want to assign a different type value to an existing. Sometimes you may also like to reuse existing variables names because you are just converting values to different types, like in this exercise. Fortunately, Cairo has a powerful solution to this problem. It's called shadowing. You can take samples of variables and shadowing it here. There's a link to the Cairo book. All right. So I think what they're saying is that you can actually rename or reset this variable, like say let number 3. I'm not renaming, I'm just defining like a new variable that is shadowing the old variable. So if I click compile, it works. And now this new variable that is shadowing the old one, they have different types, right? This is of type felt 252, and this is of type U8. So now this variable no longer exists in the context, at least from this point on. It will always refer to the last one, which is going to be 3 and felt 252. Okay. Question says, that is very weird to be OO as an OOP. Well, this is not object-oriented programming, at least not yet. I mean, there are some features of Cairo that will resemble object-oriented programming, like having methods and properties and objects, but you don't have classical inheritance. For example, you have traits. No, we don't want to make it OOP. That's the one thing I didn't like about Solidity, actually, when I was learning. This whole nonsense of extending and inheritance, I hated that. But let's see what's happening here. So we have a constant, right? First time we see this, perfect. It was number 3. So again, this is going to be a felt 252 by default. We have another constant. Now we define that it's going to be an unsigned integer of 8 bits. And it says, don't change the value of this constant. All right, fair enough. Now we have the main function where we print number and then we print small number, right? Let's see what happened. So it says, unexpected token, expected column, followed by a type. So it complains about this. So I believe the issue is here is that when it comes to constants, you have to always explicitly define what the type of the variable is. There's no, it's not like in variables when you use the let keyword that you can just leave the type out and it will default to felt 252. You will have to define a type. So if we want this to be a felt 252, we will have to define here, but I don't like felts. I prefer to use constant, right? So now this both, so this is supposed to be a small number. This is supposed to be a bigger number, I guess. So let's give it a more bigger data type, 32 bits, and let's compile again. Oh, doesn't work. So it complains about small number, unexpected token, expected column followed by a type, small number. Don't change the value of this constant. All right, so it didn't like that we use this suffix thing here. We are not going to change the value. We're just going to change how we define the data type here. Saying integer 8, right? So now both constants have an explicit data type, and then we assign the value. Let's try again. All right, let's see. The submitted code compiles, but you are not following the exercise rules. Provide code does not contain 3U8. Oh, okay. I can just leave it in still. That's fine. So I can do it explicitly define the type and then explicitly define the type of the literal expression that I'm assigning to it. So a combination of both in this case. Just because the exercise demands to be this way. It's not like you have to have both things when you define a constant. Let's try again. and it works. All right, this is done. Next, we're to primitive types. Fill in the rest of the line that has code missing. No hints, there's no tricks, just get used to typing this. All right, let's see what's happening here. All right, let's see, we have a main function, good. Every Cairo code needs to have a main function. We have a Boolean here is morning that we assign, perfect. Then we use this Boolean with an if clause. Say if it's morning, just print this on the console, good morning. Then we have another let keyword and nothing after this. Oops. And it says finish the rest of this line, like the example, or make it be false. So I say it's asking the variable to call is evening. So let's use that. And because we wanted to print the code, right? The code that is here, just gonna assign to true. So it enters the if. Although it's not really part of the exercise, you can be false as well. You just need to be completed this line. So we compile. So you can see that we learn here also to use conditionals, right? If else. That's it. Fairly simple. On to the next one. So let me give it a try myself. Okay, it says a short string is a string whose length is at most 31 characters and therefore can fit into a single field element. Short strings are actually fields. They are not a real string. Note that single quotes that are used with short strings. Okay, so this is a short string, which is basically a field just represented as ASCII, basically. And the way you know that it's a short string is just because you use single quotes instead of double quotes. And so we say, okay, so this variable, my first initial is mutable. We assign this short string, and then we say if is alphabetic, ref, my first initial. What is trying to do here? If, oh, right, this is the if. Put it here, easier to read for me. It's alphabetical, else if numeric, my first initial, print numerical. Let's take a look at the hint. No hint this time. Let's try to compile, see what the error is. Missing token terminal underscore. In line, finish this line like the example. What's your favorite short string? Okay, so here. Okay, so we basically are missing your character. Wait a second. Oh, there's a function is alphabetic. That's the part I was missing. All right, so I just need to basically define here, and I'm gonna turn it into a short string like the previous example. And what letter? Try a letter, try a number, try a special character, try a short string. Okay, let's start with a letter D. Let's see what happens. File. And it says that it has to be a mutable variable. Okay, like in the example. Let's see, mutable. Let's try again. Now the question is, why does it need to be a mutable variable? Because we're passing a reference in this function is alphabet. And to get the function, to get a reference, we need to pass it to make it mutable. Basically, it's to comply with this ref thing here. So when we assign the short string, it actually works. What happens if we assign a number? Should also work, I think, because it will go into the is numeric. Yeah. So in both cases, it works. So, but in the exercise, mostly to learn short strings. So single quotes, a letter, and it will go into is alphabetic. We'll pass it here. Yeah. Any questions about this? Why it should be mutable while passing them as ref? Right. This has to do with ownership, basically. And it means that what's happening here is that we're passing and returning ownership back to the caller. Let's see what happens if I remove the reference for is alphabetic. Let's see, do we need this? What happens if I remove ref here? Remove that, and I remove this. Argument to immutable parameter cannot have modifiers. See? Just trying to play with this to see what's happening. Just there's a lot of code, so I will need to comment that out a bunch of things. So let's try. What if I just remove? I'm just gonna leave one function if res. Let's remove this part. Let's keep it simple. It's alphabetic. It's numeric. Let's try again. Compile. I'm gonna remove the reference here as well. So it says identifier not found. Your character. Right. I think in this situation, I'm passing ownership to the function, and the ownership is not being passed back into the caller. So this is why the whole thing of mutable and ref is just a shortcut to return me the ownership of the variable to the caller. So I can continue basically for this. I think these are the assertions that we don't see, right? This is how we define the unit test, basically, behind this test. So the reason is not very clear here because the requirement is actually coming from the unit test to verify. But the main reason is that when you provide, like in Rust, the idea of ownership, you have to somehow bring back ownership to the caller. And that's what you do with the combination of mutable and reference. You pass ownership and then you return it after the function ends. We can go more into, there's a whole section for ownership in the Cairo book that I suggest you to to read so you understand better this type of situations. And I think there's some examples here of how ownership is being passed, how things are actually copied under the hood if you don't use pass and return ownership. It's an important topic. It's a complex one if you're not used to Rust, for example, but it's something that Cairo also has. All right, P3. So let's see the exercise. Destructure the cat tuple to call print on each member. So we have here a tuple. It's defined by the parentheses. So the first member is a short string, and the second member is a failed 252. It says, don't change this line. All right. And then we have another place where it's supposed to be an assignment. Your pattern here, cat. Okay, so we are supposed to end up with two variables, name and age. Because I forgot how the structuring works in Cairo, we can take a look quickly. The docs, the structuring, yeah, structuring. And we have an example where only types are defined, but I want one example where I can define the variables like this one. So in this example, I'm destructuring these three values into three different variables. So this is basically what we need to do. And you can go one step further, not only do the structuring, but also define the type for each one of them. So let's try. So let's see, the syntax is parentheses. So we have something like this, like name, age equals cat. Is that gonna work? Let's try. I think we need to define the types too. Yeah, that works. But if you want to do it more explicitly, like defining the type of each variable, we should be able to do, this is a failed 52, which every short string is. And 3, because it doesn't have any data type, is also a failed, actually. Try again. Yeah, I wonder if I try to change the type here to unsigned integer 5, is this gonna complain? It's a type mismatch. Oh, it allowed me to it. Interesting. Okay, so this is how you do structure, but more commonly you will see it like this without a type. So the compiler is smart enough to guess what the type is for each one of the members. All right, let's go next one. 1 minute on the clock, and I'm gonna lower the hands. Let's go. I just want to find the project on only Dust because people complain about the Windows issue, this the performance. I wonder if there's a way for you to collaborate. See projects. Can I search for Starlings? Yes, Starlings app. So if you have a Windows machine and you really want to fix this issue, my suggestion is to do it through only Dust. So you can fix it for all the Windows user and at the same time get rewarded by your work. Because most likely the developers of the project were using Macs or Linux, so they're not even aware of these issues with Windows. I go to Starlings app on GitHub and I see the issues. Yeah, should all start with a issue here describing what the error is. They might not be aware, but it's very important to fix. All right, let's see how many people have finished this exercise. Oh, no one has the hand up. Okay, one person, only one person. I see 4. Seems like more time. Let's give it 1 more minute. It seems to be 6 people. Let's give it a little longer just in case. Seems to be a lot here in this exercise. Ark is asking, if it takes much time, just ask them to refresh their browser. That is one thing I am doing in Windows. Also, just refreshing their browser helps with the performance, or what does it do refreshing? Yeah, Oleg is saying that yes, it will help. So try refreshing on Windows. Somehow it helps, people says. 8 people have completed the exercise. Only 8. Okay, let's take a look to the exercise. Let's see what's happening. So it says, modify the integer types to make the test pass the tests. Learn how to convert between integer types and fields. So to be ready, let's take a look here. Maybe if I can put it in the side, like the smaller font size. Try to know at casting. Let's search. Casting. Using the data types, color types, field type, integer type. Tuples, unit, fixed array size, type conversion. This is the thing we need to keep in mind. All right, let's see what the issue is. So this says to modify the types of this function to prevent an overflow when summing big values. Okay, so the issue here is because there are unsigned integers, it's very easy to overflow, right? They're very small. So what can we do? What if we increase this to so if I just put U32, let me see the test because there's a test here. The test some big numbers. So it's using this function, some big numbers, and it's passing U8, right? Modify this test to use the correct integer types. Don't modify the values, just the types. See how using the U8 suffix on the numbers lets specify the type. Try to do the same thing with other type integers. If I try to run it, in this case is just run the tests. Let's see what error we're getting. Unexpected return time. Expected failed to 52 and found a tuple. What is this? Convert to failed. So here, this one is not working because there's no implementation. Okay, so let's do this instead. Start here. It says that we need to convert an unsigned integer to failed. So a small number to a bigger one, or at least bigger data type. And we can see that in the examples, it says that when we want to go from a small into big, we can right? So I'll do x into, should be all really, because should be able to infer the type, I think. Let's try. Yes, that's all because you can see it's showing just a different error. So notice that I'm just using this method into just to be able to turn a variable of type 8 into another variable of type 252. And because if I don't put a semicolon at the end, it's just automatically return the type from the function, similar to Rust as well. So the one that is failing is this one, which is doing the opposite. Just take a variable with a big data type, and we're supposed to return another variable with a smaller data type. So here, what we do is try into. And the reason we use is called try into and not just to into. It's just because this operation could fail, right? Because sometimes if the number stored in the variable is too large and it doesn't fit in 8 bits, it's not going to be possible, right? It's going to fail anyway. So we're going to have to unwrap it. Right? So in case if it doesn't fail, give me the value. If it fails, it's gonna fail because otherwise it will give you back some kind of enum that you have to take care of it. So it should be all. We don't put the semicolon, so it returns the value. See? All right, making progress because at least we see a different issue here. It says the value does not fit within the range of unsigned integer of 8 bits, and it's pointing to this assert, some big numbers, blah, blah, blah. So it's pointing here, right? Line 29. The value does not fit within the range for integer. Why? Oh, okay. I see why. Because the maximum value you can store in 8 bits is 200. 510 is too big to fit into an 8 bits. So first of all, we need to change this to a bigger data type. Let's say, for example, U32. We could have used U16, but this is a common type. But if we make this change, right? If we try to run the test, the issue is not going to be with the implementation itself. There's some big numbers because still says U8, right? So we need to make those two things match. So let's call this the same type, U32. But now we have the issue that if we add two variables who are unsigned integer 8 bits, the result is going to be, in theory, the same type, unsigned integer 8. But let's check. Oh, this time it's taking a while to run. All right. Unexpected return type, expected core integer U32. Yes. So if you sum two unsigned integer 8, the result is unsigned integer 8. So we need to first turn these numbers into a bigger data type. And we can do that with the keyword into, right? So from a small data type into a bigger data type, you can just use into. Is that gonna work? Yeah, right. So the compiler knows to pick up U32 as the target data type. So we bump it up to the data type and now it's able to handle bigger numbers. Question from Zachary, what is the advantage of having all these different number types instead of just having integers? You can more carefully control how much let's say memory. It's all about the cost, right? Gas. handling all the things in U256 is going to be more expensive than handling numbers with a data type that is small but good enough for your use case. So it's all about cost. If you don't care about cost for some reason, then just use the bigger data type, but your users are going to pay for it. Hopefully that's clear. All right, this is completed. Any question about this exercise? We could have made use of this function, by the way. Let's try to do it with these functions because we fix them, but we never use them. So let's define that the type here is felt to 52, which I don't like. Let me see if convert to felt. Let's use it just for the sake of the example. If this scenario, I should be able to use convert to felt here too, and then turn here the type. Which way, if I remove the type, is by default felt. So this should work as well. Oh my god. Click the wrong. Ah, so gone. Well, okay. Hopefully you knew you understand what I was trying to do, but the exercise was completed before. I was trying to use the functions but I don't like using felt to 52 for anything. So it was just an example how to use a function within a function. All right, next exercise. Let's see what's happening here. Operation number 1. Integer types implement basic comparisons and arithmetic operations. Failed to 52 operations should be avoided where possible, as they could have unwanted behavior, which is this overflow and underflow. So let's see what's happening here. So it says return the solution of x to the power of 3 plus y minus 2. We are provided with two variables, x and y, of type usize, which is the same as, say, u32. Also returns usize. We are supposed to provide the implementation and return a variable called res. And this, the function or the test for the function is that if I pass exactly 126, I should have an error message. You know, if I call the function find 3, oh, okay, no. If I pass 5 and 3 to the function, if the return value is exactly 126, there's an error message because I'm guessing it doesn't comply with this polynomial. Let's see. Let's just try to implement this function as is described here. How do we go about it? Let's see. Let's call it x3, right? This is x to the power 3. What if I just do x times x times x? Simple one. And then I define that res is going to be equal to x3 plus y minus 2. Is this going to work? Yes. Now the question that I have, is there a function for power? So I don't have to do this manually. They used to not have one defined directly. I wonder if that has changed. So we can take a look at operations. And let's see which one could be. None of the basic operations are doing that. Power. Yeah, I don't think there is a way to directly with the language to use power like a math function. But there's a library called Alexandria. Starknet. So this is something that I use whenever I want to do more advanced mathematical functions. On a smart contract, I would import this library into my smart contract, so I will have access to all these features, which probably includes math and would include something like power, fast power. Yeah. But in Starlings, it's a very basic environment. I cannot define these dependencies, so I just have to use whatever is defined directly on the language, which is just multiplied this way. Unless you guys have a better solution. Why does raised to power or exponent does not exist in Cairo? It doesn't exist in Cairo directly at the low level, but there are libraries you can just import. But this is possible when you use Scarb as your dev environment. You can define import libraries, not in Starklings. All right, Fabian is asking, I'm on the loops exercise now. The primitive type stuff was quite hard though. If you get stuck, go to Discord. Maybe your peers can help you out with some of the issues that you have. We only have 15 minutes left onto the session, so I just try to do a couple more. But yeah, Discord is the place to get support from your peers and from myself as well. I'll be there. All right, let's go to the next one. Operations 2. Okay, let's take a look what's happening. Operations 2. Cairo has native integer types. Example, U8, U32, U56, usize, which support more operators than fails. And always watch out for overflows. Example, in the last test. Let's try use them. Okay, let's see what's happening here. We have a function called modulus, where we pass 2u8 and return u8. Calculate the modulus of x and y. Feel me. How is this being used? Let's take a look at is someone using modulus here? Yes, we have it here. It says if I pass 6 and 2, so 16 modulo 2, so it should be 0 because it's an even number, which is what's expected, right? It should be 0, otherwise here's the error message. So the modulus operator, if we go back to here, we can see is what is it? If I use mod operators. Yeah, it's the remainder. It's the same as the modulus, right? So it's this one here. So okay, so I'm gonna say create the variable res, and it says x module y. So this should fix at least this one. The first one. Let's see. So it complains about line 10. All right, it complains about this not being complete. Fine. Let's move on to the next one. Floor division. Let's see how is this expected. So I divide 160 divided by 2 is expected the value to be 80, otherwise error message. But if I divide 21 by 4, it expects 5 just because it's looking for the lower division of it. Let's do a simple division and see what happens. So I do res equals x divided by y. Let's try again. We can finish this already. Multiplication, I just guess you just want to multiply x and y. Let's do that. Equals to x times y. Now let's run all the tests. Oh, and this works. All right, it was pretty simple. You just define modulo, so you know the operator is this simple division. And notice that division works well with no these shenanigans of the prime number being in the middle somehow. That's just because we're using u size or unsigned integer. So ua, u16, u size, they all give you whatever you expect math to work. When you use fails, sometimes you have unexpected results. That's what I'm saying. Try to avoid fails much as possible, unless you really know what you're doing, because you're trying to do some crazy optimization in terms of storage and performance. All right. Next one. So what's happening? Complete this function to return the bigger number. So we have the function bigger. It's passed two values, u size, the type, and we're not supposed to call any other function. We're not supposed to create additional variables. And the test, this is how you write unit test, by the way. You use this attribute and you encapsulate this into a module. So it brings the function into scope here. This is how you define, say this function is a test, it's a unit test. So it says 10 is bigger than 8. So if we pass 10 and 8, it's supposed to return 10, otherwise fails with this message. And 42 is bigger than 32, very self-explanatory. Okay, so this is a usage of if-else, basically. Let's remove this. And it says, okay, so if A is bigger than B, then return A, else return B. What happens when they're the same? There's no test case talking about that, so this right. What can I do differently here? Forget if I have any ternary operators. I don't think though. The only thing we could do differently is maybe the return could be optional, right? Removing the semicolon, this should work as well. Oh my god, click the wrong button, but it's okay. It's a simple one. A is bigger than B, return A, else maybe it's a more compact way to write this. Test. Yes, it also works. Just because in Rust, if you don't define return, it's just you're going to make it explicit, but if you don't use return, the last thing provided in this block without a semicolon is going to be it almost look a ternary operator, but it's not quite. Okay, next. Let's do it. Maybe this might be the last one we do because we're close to the 2-hour mark. So this is the last we resolve here, and it says, when we compile step 2, get the bar for fuzz and default to bash test passing. Okay, complete this function using if, else, and other else blocks. If fish is fish, return foo. If it's fuzz, return bar. Anything else, return bass. Okay, we have the first one. If fish is fish, return foo. That seems to be fine. Now, if it's fuzz, return bar. So we need another, I think it's if else. If else combined, one single word. Let's say control operators. We have the regular if and else. I forgot how to do the if else. A single, oh, it's else if. All right, that's what I got it wrong. Else if Second option will be for physically bus. In that case, you're gonna return a bar, right? And it says anything else, return bus. You have a final else, no if, that just returns bus. It should be. Yeah, okay, completed. Perfect. 10:56. So let's stop here because I tend to go over time every time. So just a reminder, what we covered today, we just discussed a bit of the what Cairo is, what the meaning of the language, the Cairo CPU or the CPU air, a bit of the history, like the old Cairo assembly versus the new Cairo. We talk about some of the milestone of the developing this technology, the fact that Cairo was developed for StarkX and now then brought it to Starknet. And we talk about fails as the fundamental data type for Cairo and Cairo VM, and the fact that just because it brings to the realm of mathematics, field operation, everything is applied modulus, a large prime number that takes 252 bits for storage, which means that any operation, multiplication, addition, could overflow or underflow. And division is done by the Euclidean divisions and the different types of division. That's why sometimes it gives you unexpected results, which is mathematically correct, but not what you expect on a program. That's why to avoid all of those issues, always use unsigned or signed integers in your code, so you will never have those issues. If some variable try to overflow, what you're going to get is just an exception in your code, but at least you will be able to know that it's failing. It's not going to fail silently when overflows. And we started to solve Starlings live in the browser. I know some people have some issues with Windows, but the rest or completing the whole of Starlings is the homework for Basecamp. So make sure you finish it before Basecamp ends because that's going to give you 20 points toward graduation. That's all for me today. If you have any more questions, this is your time to ask them. Otherwise, if you're done, remember there's going to be a feedback form as soon as you click the Zoom client. It's been a pleasure to be with you all. We have more than 100 people again today live. Session 4 next week, next Thursday. We're going to take what we learned about Cairo. Hopefully, that's why it's important that you finish Starklings, so you have a very good idea of Cairo itself, because we're going to use that knowledge to now build smart contracts on a Starknet using Cairo. Right? Thank you very much. Bye-bye.